organisms is challenging, difficult. And then we said that when all is said and done, if we've discovered every living thing on Earth, we will have discovered about 12 million, maybe 10 million, maybe 15 million, maybe more unique species. That's a lot of stuff to keep track of. So, with that in mind, you can't do biology until you start categorizing things. So, a picture of here. And breeds of dogs. And then I've got a picture of what's going on here. A horse and a zebra, or if you prefer, a zebra. And how British your pronunciations are. So, why do I put these pictures up? Why do I put these pictures up here? Sure, so we got a bunch of different dogs. What's different about these dogs? Like that's a dog, but that's also a dog. That's a dog. We call them all dogs.
Different breeds and different heights.
Okay, the different heights, the different breeds. What does that mean, different breeds?
They're mixed between two different animals.
And see, this is good. Different animals. I like that. They're definitely different types of animals. A Chihuahua is not the same as, I can't quite see, is that a poodle or is that like a dog?
Golden poodle, I think.
That might be a poodle, might be a water dog. My uncle had a Portuguese water dog. That thing was enormous. It stank all the time. That might have more to do with their bathing habits than the dog naturally. Here's an interesting thing. These are very different animals. Yet, biologists classify these all as dogs. Not just all as dogs, though we do. These are all the same species of animal. Species. Whereas a horse and a zebra, which look a lot more alike than a Chihuahua and a whatever the hell this thing is, I think we decided these two look a lot more alike than those two, don't they? These two are totally different sizes. They have different shaped faces, different shaped tails, different legs. Their hair patterns are radically different. They have different personalities, different behaviors. Same species. These two, different species. So break that down for me. Why is that true? Is that just scientists being difficult? Do we just like to... Does it have to do with where they live? Why in the world do we say that these are all the same species and these are different species? First of all, what's that word species mean? Yeah.
Kind, the category of a certain animal.
These are good languages, definitely. A species is a category that we've built. It's a name that we give to things. And we say things are the same species if what? Good thinking, but we have a common ancestor with another thing I'm thinking of right now. It's called a carrot. And we and carrots have many common ancestors going way back to our evolutionary history, and yet I would say we are not the same species. Though I've taught some students who might convince me otherwise. But I like the thinking. It relates to that. Yeah.
They both evolved from a certain group, like wolf. They all
Okay, you're on the right track. So not only a common ancestor, but like a common ancestor pretty recently. We're not talking way back. Yeah. We and carrots both have single-celled ancestors way back 4 billion years ago. You're saying they have recent common. I like that. That's good. And that does play into everything we're going to talk about today. But it's not the definition of a species. In biology, we say two things are the same species if... Well, there's something we know about dogs, which is if I take one of these and she spends some time with him, one of those, what will I eventually get?
Puppies.
I'll get puppies. Even though they're different dogs, I will get puppies. And those puppies will, in all likelihood, look like something of a blend of the two of them, right? They can breed. And can those puppies then breed with other puppies found somewhere else?
Yeah.
Provided they can kind of any two dogs can breed with another. Right? Any two dogs can breed with one another. Whereas, well, we'll get to it. So the classic definition of a species is two organisms, I should not say animals because this does not only... Two organisms are of the same species if they can reproduce with one another, conspicuously missing no period at the end of that sentence. Am I just using bad grammar, or is this going somewhere? Two organisms are the same species if they can reproduce with one another. So these guys are the same species because they can reproduce, they could reproduce, they could reproduce. You put any two of these together. Now, does that mean that individual cases may not be able to reproduce? Of course. In any species, there's a spectrum of fertility, but examples of this species can reproduce with examples of that species. Great. That means these are the same species and these aren't. Except for this guy, and that's a real picture. Or it would be if I had zoomed in and it hadn't immediately disappeared. What the heck is that? Yeah, most commonly I've seen it referred to as a zorse. But believe it or not, if you put a zebra and a horse together, they can reproduce, and yet we said they're different species because this thing has an interesting characteristic. It is a real animal that exists, and yet it is sterile. It's infertile.
So like a mole?
A zorse can be born. You can breed a zebra and a horse, but what you get, product, is infertile itself, which means you can never then get a population of zorses that is self-producing. Does that make sense? You can't make a zorse using two zorses. I'd like to never say that word again. You need a zebra and a horse. So for that reason, since this can't reproduce with another one of its type, we say that it is not a fertile offspring. So two organisms are of the same species if they can reproduce with one another to produce fertile offspring. And what does the word fertile mean? Able to reproduce, that's right. Fertile offspring. And so, you're only of the same species if you are able to produce with one another to produce an offspring that then is also able to reproduce, that then is also able to carry those genes on into the future. And let's make a note to ourselves in case we don't know what that word means, that fertile means able to reproduce. Fertile is the adjective form. Fertility is the noun form. Fertilize is the verb form. When you put nitrogen-based products on your lawn so that the grass can grow. Actually, bad name because you're really not encouraging reproduction of grass so much as you're just encouraging its natural growth. But anyway, that's neither here nor there. Okay. So this is the classic definition of a species. And by that I mean this is the definition that scientists have most commonly used in the past to define a species. It itself is not a perfect definition. And you're going to find that that comes up over and over again in biology. This world is complicated and there's a bunch of different stuff out there. So every definition we come up with is going to have things that make it imperfect. Every definition we come up with is going to have examples that make you go, well, that doesn't really work. And there's just kind of no getting around that because the world's just a big, complicated place. Does that make sense? But this is basic definition. Now, a horse and a zebra can produce an offspring, but like we said, it can't produce a fertile offspring. And, oh, that sentence got cut off. Whoops. But there's three kind of ideas we get that we use to talk about species and how related they are. Sorry about that. Oh, what happened there? This is what happens when you are trying to play trucks with a 8-year-old while also making a biology note. Goodness knows what you'll probably find in here at some point, like me talking about being a front-end loader. I always the front-end loader. That's about when I try to be anything. I go for that excavator. Oh no, only the front-end loader. I'm a real one-trick pony at the construction yard, apparently. Okay, so there's kind of three ways that scientists think about species. So it's easy to say what a species is. Okay, if two things can reproduce and produce a fertile offspring, it's great. But now yesterday I gave you the task of talking about grouping species together, right? Now that we know what a species is, pretty easy, see if they can reproduce or not, see if when they reproduce those offspring are fertile, great. Now we can figure out everything that isn't the same species, we identify the different species. Now, as scientists, we need to start grouping them together so we can think about them and talk about them. And that's what this whole lesson is going to be about, the ways we do that. But what's your philosophy there? Because, here's a grouping that nobody came up with, but you could have. I could put these together. This is a grouping. I think it's a stupid one, but I think it's legitimate. What was my grouping category here? Yeah, it's green in it. Now, is that a good grouping philosophy?
Yes.
Probably not. But does it work? I mean, could you do that? Sure. And for the record, there are times when color is something we use to group things, amongst other things, right? So how do we group things? And there's basically three major ways we do that. The first is what we call the morphological species concept. And this is the idea that we group species based on morphology, morphos. There's a Greek word for you, morphos. What word mean? Man, if we all spoke Greek and Latin, science would be so easy because biology is Greek and Latin derivatives. So morphos, yeah.
Like it changes.
Ooh, we think of morphing meaning changing, and that's a very good thing. It actually doesn't quite mean that in its original meaning, though it's totally related to that. When we think about morphing, the way we use that term, we think about something changing its... We think about them changing their shape. Morphology refers to shape. This is the Greek word for shape. And so when we talk about something morphing, such as the mighty morphing Power Rangers, they change the shape. I mean, really, they just changed their costumes. Really, they change into entirely different people because the whole point of that show was that there was a Japanese show that had been filmed and produced there. And to make it an American show, they just filmed whole new sections with actors out of costume, but used all the Japanese footage for the fight scenes and the battle sequences. And so, yeah, it's a true story. Look it up.
Can a horse or something that's not bred like a horse be like infertile, like an infertile human?
For sure, yes, absolutely.
Like it could a horse have PCOS?
Yeah, great question. Absolutely. Any individual in a species can be infertile, and that doesn't say anything about them not belonging to a species. So when we talk about can reproduce fertile offspring, we mean some of them. You're going to have infertile examples of any species imaginable. I mean, right down to the point of, I have a peach tree in my backyard that will not be peaches, which is, for the record, how trees reproduce. Just won't do it. Just won't. Got 13 trees back there, one of them, no fruit, ever. That's a thing. And that is an example of tree infertility. It's the exact same thing. Sorry?
Peach tree?
I have 4 peach trees, 4 apple trees, 2 apricot trees,
Where's our
2
peaches?
pear trees.
Yeah.
Where's our apples and peaches?
Let me tell you something. These trees are my wife's little passion project, and I've done the math, and I'm pretty sure every peach I've ever eaten from those trees cost about $800. But that's okay. It makes her happy. She goes out and she tends the trees, but they don't make a lot of fruit yet. I am told by my wife that any year now they're really going to start going. Actually, I shouldn't say that. We got a good bunch of peaches this year. But the apple trees, it's 3 apples a year every year. It's like you, and then this one peach tree, nothing. Just not a bud, not a flower, just nothing. But the reason for that being, yes, within a species, different individuals have different traits, as we know, right? I mean, these are all the same species, but they're all totally different. And so individuals within any species can potentially be infertile. That doesn't mean they don't belong to that species. When we talk about fertility being the guideline for species, we're talking about it being like when you take the whole group. If you took 100 of these and 100 of those, some of them should be able to reproduce. And that would tell you that they're the same species. Did that answer your question? Good. Yeah.
So a different species is almost like a donkey and a horse making a mule.
Yeah, exactly. Donkeys and horses are different species. They can reproduce, they can make a mule, but mules themselves can't go out and start mating, and now you've got a big colony of mules. The only way you get a mule is with a horse and a donkey as parents. Great example. Yeah?
We have categories inside species.
Yes, and we're going to talk about that. Yes, absolutely. We call those breeds. Well, mostly we call them breeds, though there's different. Anyway, so in the morphological concept, we group species based on their shapes and other observable traits.